Okay, so last class we took a look at scatter plots. We talked about the fact that a scatter plot helps us look at the relationship between two numeric variables. And we talked about when you're describing a scatter plot, you're going to use FUDs, you're going to take a look at the form, anything unusual, the direction, and the strength. What we're talking about today specifically is this idea of correlation, which you read about. So today, all correlation. We left off with that scatter plot, so this is where we are now. What is correlation? Correlation is a supplement to help describe the strength in a scatter plot. So when we took notes on Monday, somebody asked, how do you know if it's weak, moderate, or strong? You know that based off of the correlation. You can take a guess or estimate visually, but the correlation really helps us narrow down is this a weak, moderate, or strong relationship. This is for a linear relationship only. But it does not tell us form. So what I mean by that is we can calculate correlation for any scatter plot at all, but it only makes sense if the data is linear. So on the first problem from the warm-up where it was a curve, we can calculate correlation. It's just not particularly helpful. It doesn't give us much information because of the fact that the data is not linear. And then scatter plots in general, if we remember, are for two numeric variables only. So we are always looking at the relationship between two numeric variables. I forgot to mention this to you. This unit is very important, and it's going to be a big part of the AP test, so I just want to make sure you know that. Some characteristics of correlation that you read about. The first one is that correlation is always between -1 and +1. And R is the symbol for correlation. If R is less than 0, that is a negative association. So a negative slope. If R is greater than 0, it's a positive association. So I guess above, I really should have put that R helps us give us the direction and the strength, but it doesn't tell us form. An R value that is close to 0 tells us that there is a weak linear relationship. There could be a different type of relationship, though. And then if R is positive or -1, that is a perfectly linear relationship. And then lastly, this came up in the last warm-up problem that we did. R is not affected by which variable is X and which is Y. So if you switch X and Y on your scatter plot, it doesn't change the direction, it doesn't change the strength. R will be the same. And then here are the ranges to know. If R is between 0 and 0.5, that is a weak relationship. Between 0.5 and 0.8, that is a moderate relationship. And between 0.8 and 1, that is strong. And then, of course, it is the same for the negatives. So R of 0.7 is a moderate positive relationship. But same if we have negatives. Mm-hmm. Questions? Okay. Moving on. Which association is more linear? One that has an R of 0.5 or one that has an R of 0.9? So generally, we're thinking 0.9 is closer to 1. It's going to be stronger. That being said, we can't actually tell because we need a graph. R is just a supplement to a graph. So we don't know anything about R unless we see the graph. Here is an example. If you were to look at the graph of y equals x squared, would you call that linear? No, right? We would definitely call that curved. If we look at x being between 0 and 10 for y equals x squared, the R value is 0.97. So that's a really strong linear relationship, even though the data is not linear. So if you were just to see R, you would say, oh yeah, this data has a linear relationship, but it doesn't. When you look at the graph, you would see, well, a curve is a better fit. So R is only a supplement. If a correlation is near 0, does that mean that the association is weak?
Again, we can't tell.
No, because the association could be nonlinear. R only tells us the strength of a linear relationship. Okay, is correlation a resistant measure of strength? So this one I think we can probably figure out. If we have this data set, resistant means affected by outliers. If I put in a point here that doesn't follow the pattern, do you think it will affect the strength? R. Yeah, it definitely will. So is correlation resistant? No. Now, we could get an outlier that is in the pattern or that's out of the pattern. So the one that we have right there is out of the pattern. So out of the pattern means that R will get closer to 0. Because the point does not follow the pattern. Now, if I put a point down here in red, that one is an outlier still because it's away from all the data, but it follows the pattern. So it follows the pattern, but it's far away from all the data, so it is going to have a pretty big influence. Because it is in the pattern, R will strengthen. So either it gets closer to 1 or -1. In our case, -1 because it's a negative relationship. So anytime that you have an outlier that's within the pattern, unusual within the pattern, R should get closer to 1 or -1. We still doing okay? Yeah? Okay, we already talked about this. Does it matter which variable is X and which one is Y? No, because we're just looking at strength. Okay, you have 4 different scatter plots here. Notice that most of them have the same values on the x-axis between 4 and 16. The last one, though, goes from 8 to 20. I want to know which one you think has the highest correlation. So talk to the person next to you. Come up with which one do you think has the highest correlation. Okay, let's take a look. Raise your hand if you think the first one has the highest correlation. Okay, second one? Third one? Ooh. Fourth one? Okay, you ready? You probably know the answer if I'm asking you. They're all the same.
Of course they are.
Yeah, they all have the same R. Here's the lesson that I've said, but I'm going to say one more time. You need to plot and look at the scatter plot. Before calculating R.
I'm pretty sure we all just looked at the graphs
Yep.
first, but then did not do any calculations.
So R is just a supplement to the graph. Okay. We are going to write down this last thing about how to calculate correlation, and then we will take a break. Here is the formula for correlation. What you will do is you will calculate a z-score for x and a z-score for y for every point. So for this point right here, I would calculate the z-score for its x and the z-score for its y. What do you need to have to calculate a z-score?
Observation, mean, and standard deviation.
Okay, so we would need to find the mean of all the x's and the standard deviation of all the x's, the mean of all the y's and the standard deviation of all of the y's, just to be able to find a z-score for x and a z-score for y. So we would need the mean of x, the standard deviation of x, the mean of y, the standard deviation of y. Then for every single point, we're going to convert both x and y to z-scores. We're going to multiply them. We are going to add it up for all the points. And then we will divide that whole quantity by n minus 1. Do we see that that would be a ton of work? Of course, the calculator is going to do it for us.
Wait.
I lied. I have one last thing to write down.
Oh, wait. The top one is multiplying, right?
Yep. Okay. Do you remember how we have different symbols like x bar versus mu, s versus sigma? What is the difference between the one on the left and the one on the right? So what's the difference between x bar and mu?
Something and then population.
Okay. So these are for a sample, and these are for the population. The same thing is true of R, so I just want to make sure you see the other symbol. R is the sample correlation. If we happened to have all of the data for the entire population and calculated R, the symbol is rho. It's like P with a little tail. That's rho. Okay, so there's an example on the next page. Here are data on the lengths in centimeters of the femur and the humerus for 5 specimens of whatever that word is that preserve both bones. So I would like you to do part A. Make a scatter plot by hand, please, and then describe what you see. Here is what I ended up with for my scatter plot. You guys end up with something similar? Okay, would somebody be willing to read their description?
I can read the first sentence I
Sure.
have since that's the easiest.
That would be lovely, thank you.
Well, it shows a linear relationship between the size of the creature's humerus and femur.
Yeah. So there is a linear relationship between femur and humerus for these 5 specimens. That's important. This is not, we are only describing these 5. We don't know the relationship between all femur and humerus lengths. Okay, so linear, what else would we say? Positive. Strong. So there's a strong positive linear relationship between femur and humerus length for these 5 specimens. Anything unusual? I wouldn't really say so. You might consider this one unusual just because it's a little farther off, but it still follows the pattern. Okay, sound good? We need to find the correlation. So this is where we're going to use the calculator now. So if you don't have your calculator out, if you would take it out, please. Here's what I need you to do. Some of you, I think, figured this out from your reading. I want you on your calculator to go to list 1 and put in all the femur lengths, and then go to list 2 and put in the humerus lengths.
Where?
List 1 and list 2. So you're going to have to hit stat and edit, and that'll bring you to your lists. If you have anything in the list, you can always clear out the list.
For some reason it's not.
Is anybody missing a list 1 or 2?
I'm on list 3 through 5. I don't know how to.
Okay, so if that ever happens, what you're going to do is if you go to Setup Editor and hit Enter, it'll bring all the lists back. When you go to your list, make sure you hit Clear and not Delete. If you delete, it will delete the list.
Oh, okay.
When you've done that, quit out. The order you put these in is very important. The calculator is going to read this as 1 point, this as 1 point. So what I'm saying is don't go 38, 56, 59, 64, 74, and then all of a sudden enter them backwards. Does that make sense? Like it's going to read the first 2 together and so on and so forth. There are 2 things I want to talk about on here. The first one is how to take a look at the scatter plot. Can you right now hit y equals and make sure you have nothing in y equals? We all have nothing in y equals? So then quit out. The way to look at a scatter plot now, so for the scatter plot, you are going to go to second, stat plot. That's the y equals button. So hit second and then the y equals button, and it should say stat plots 1, 2, 3, 4. Yeah? Go to 1, turn it on, and then you should see 4 different kinds of graphs under type. You want the first one. That is the scatter plot. It has the dots. Everybody with me still? And then to actually see your scatter plot, you'll go to zoom 9. And you should see a scatter plot that looks exactly like the scatter plot you drew. Can you show your scatter plot to the person next to you to make sure you guys both have a scatter plot and they look the same?
What do we do from here to
Hit zoom and then the number 9.
okay. Zoom 9. Ah, there we go. Wait, that does look. This does look like what I drew. Scaling's a bit better. Yeah, that's good.
Everybody else got a scatter plot. Okay, great. The next thing is for calculating R. The next thing you only have to do once or if your calculator dies. Your calculator comes with R turned off. So we need to go in and turn R on. So make sure you're just in the general calculator screen.
Wait.
So what you're going to do is you are going to hit second catalog. Catalog is above 0. And then you should see a list that starts with ABS. It's ABS, and angle, ANOVA. We all looking at that? Okay, what you are looking for is diagnostic on. You can scroll down, or you can just do alpha D. You do alpha D, you're going to find there's diagnostic off and there's diagnostic on. When you get to diagnostic on, you're just going to hit enter, enter again. And it should say done. Okay. R is now turned on. If your calculator dies, it will be turned off again, and you'll have to go back and turn it on. But otherwise, it stays on, and it's not going to affect anything else in your calculator. So lastly, how to find R now. You're going to hit Stat. You're going to go over to Calc. And then you're going to see number 4 is linear regression, AX plus B. Do you see that? Okay. For some reason in statistics, I don't know why, we normally put the y-intercept first. So can you scroll down, and just off of this screen, number 8, you're going to see another linear regression. So if you go to Stat Calc, 8 is going to be lin reg A plus BX. Ultimately, they're both the same. But in stats, for whatever reason, we tend to put the y-intercept first. So you're going to hit enter on number 8. And then some calculators, it's going to say X list, Y list, frequency. It should just automatically put L1 and L2. If you don't, so Sam, I bet your calculator does this, your calculator is going to assume list 1 and list 2. And so as long as you use those, it's going to use the right list. Hit enter. And what you should see is A, B, R squared, and R. And your R should be 0.994. Is that what you guys got? Great. So if you're actually doing this, calculating correlation, what I expect to see on your homework or on a quiz or a test is you're going to write out the formula and then just give me the answer. R squared, A and B, you're also going to need eventually, just so you know. So if we can see that it's y equals A plus bx, if we look at that A value and that B value, this is giving us the equation of the line of best fit. So I just rounded A and B, but that's how you would find the line of best fit. I expect you to calculate R using the calculator, not by hand. So all I want is show me the formula once and then take it off the calculator. This R value, very close to 1, so it does confirm what we saw in the scatter plot, that this is a strong linear relationship. Any questions on the calculator stuff? Okay, that scatter plot will be turned on from now on, unless you go back in and turn it off. So if you use your calculator a lot in your science class and you look at graphs on your calculator, you might want to just go back in and turn it off so you don't see the scatter plot anymore. Okay, questions for me? last thing to write down then. What are some additional facts about correlation? Really the big one is that correlation is not affected by units. So the example above, the femur and humerus were measured in centimeters. If we change those to inches, we would get the same value of R.
As long as the units are still the same. I'm just assuming you can't use, if you said 1 meters, 1 centimeters, and
R will stay the same.
I'm just sure as long as the two things are equivalent.
Ah, I get what you're saying.
Essentially, as long as the values you put in
Yes.
with the unit.
Yes. So what Luke is saying is they're both in centimeters right now. If we change femur to inches, but we keep humerus in centimeters, that's kind of a... No, it would still be fine. Still be the same. Okay, this is the one really, really big thing I need us to get from today. That correlation is not the same thing as causation.
Yes. I was waiting for this to show up.
So just because there is a strong relationship between two variables does not mean that one causes the other. Oftentimes, there's another variable involved. So one example that is really common is if you look in a town at the number of churches the town has and the number of bars it has, there's a very strong relationship. So does that mean that if I go into a town and start a new church, that a new bar is going to pop up? No. In all likelihood, what is the third variable that those two are related to? Kira?
How many people are in the town?
Yeah, the population, right? Larger population is going to have just more places in general.